Hi, my name is Kaufmann, and this is the story of my affordable electric bike kit. I want to start by thanking my family for the role they had in this. My family has always been there for me. They were my first advocates, they were my first cheerleaders, and they have always been there to support my ideas and me as an engineer. Unfortunately for me, none of my family members or parents are STEM majors. This has created some more academic balance in my life, and I feel like I have more of a balance between the disciplines of STEM and humanities. It has made it harder to find connections to internship opportunities, advice on projects, mentors, and support. So, for the majority of my time as an engineer, all of my skills, knowledge, and learning experience have come from my own self-directed projects. This has been a uniquely satisfying, enjoyable, and life-changing experience, and truly I wouldn't trade it for anything. I started building as early as 2017, the extent of my tools being paper, pencil, and a handsaw. I've since slowly built up my arsenal of tools, and I'm truly grateful to possess the resources and tools I have today. In the past, this has been a little bit annoying. Not having access to expensive lab equipment, CNCs, laser cutters, or any of the machines that a modern engineer would have access to has made it slightly more difficult to manufacture the many parts that I make today. Despite this, the absence of these tools has enabled me to truly appreciate the gravity of their usefulness. It has also enabled me to find solutions and workarounds to many of these tools, like 3D printing instead of CNCing parts, or even building my own CNC router. The e-bike story begins way back in 2020, when I first had the idea for the project. At that point, I had very little experience, and it was not enough to get me through even the early stages of planning for the project. At that point, I had just gotten a 3D printer, and I attempted to 3D print many of the parts that I needed for the project. Not surprisingly, the project was a failure, and I abandoned it for a couple of years. Fast forward 2 years, and I was working on my own CNC router. The CNC that I made is mostly 3D printed, so it does not have the rigidity to mill harder materials like aluminum or steel. It does, however, have the capacity to mill PCBs, and I've used the milled PCBs from this machine pretty much on every single project since. That same year, I gained free audit access to 3 MIT electronics courses, and over the course of the fall of 2022, winter 2023, and early spring, I took those 3 electronics courses. That same year, I also took AP Physics C, Electricity and Magnetism, and the content I learned from both of those courses enabled me to have the knowledge base to start working on the new version of the e-bike. Now that we've reached the point where I'm finally working on the e-bike, I can take you through some of the design challenges and issues I faced while working on the project. To start, I would need to design a circuit that was able to control the motor I chose for the project. This was a 3,000 watt brushless motor at the time, and I had not yet decided to manufacture my own motors. Because the motor was brushless, I would need 3 half-bridge setups, or totem pole setups, to actually drive each of the 3 phases of the motor. These 3 half bridges combined would be able to produce the 3-phase AC that a brushless motor requires. While most sensible people would buy MOSFET gate drivers, at that point I hadn't done my research into MOSFET gate drivers, and I instead decided to try designing my own totem pole driver. This required using and designing upwards of 5 or 10 bipolar junction transistors. It would also need 5 or 6 resistors for current control and 1 capacitor to bootstrap the high side MOSFET up to a higher voltage. This expectation was way beyond my manufacturing abilities at that point, and unsurprisingly, I immediately ran into significant issues. At that point, the only device I actually had for troubleshooting was a digital multimeter, and trying to troubleshoot complex digital circuits with a digital multimeter was not the right way to go. Despite this, I had no other options for troubleshooting, and I spent upwards of 2 or 3 months working on this specific problem. Nearly every day from 3 p.m. to 11 p.m. after school, I would come home and sit at my desk trying to troubleshoot the same exact problem. It was at this point that I realized I'd truly hit a maximum for the equipment I had, and I decided to invest in a digital oscilloscope I found on eBay. This digital oscilloscope has been a monumental addition to my arsenal. And spending the money to purchase it also reminded me that I might need to take a step back and consider spending money on some MOSFET drivers. I also decided at that point that my overall needs had maxed out the abilities of my CNC, and I decided to outsource production of my design to JLC PCB. Unfortunately, because the manufacturer is in China, it did take about a month to come unless I wanted to pay $70 for shipping. But the PCBs were relatively cheap and they were very high quality. The combination of these two changes has been by far the most impactful change I've made while working on this project. I have hit another roadblock, which is that the 3D printed motors I was designing simply do not have enough iron content. And to make better motors, I'd like to manufacture some in sheet metal and stamped sheet metal or plasma cut sheet metal and stack it between insulating layers to reduce eddy currents. This would increase the overall iron content of the core and would allow me to make custom motors I can use on my e-bikes. Since my CNC can't cut metal, I haven't been able to do this, and it is my goal to try to make a CNC that is able to cut metal in the next year or so. More of the specific project details for the e-bike can be found on the other documents of my application, so I won't go too much in depth on it in this video. I will wrap up by saying that I believe the e-bike truly has potential to contribute to society. Funding myself and having the awareness that not all of the technologies in our world are accessible to everyone has been truly a driving factor for this project. I think the drive and skill to reduce the cost of the e-bike project has stemmed from the occasional difficulties to source funding and resources in my other projects. It has also been a driving factor and a reminder that there are many other people who are worse off and have less resources than I do. If there's something that I'm struggling to obtain, I can't imagine how hard it is for them. Upon releasing this product, I truly hope and believe that it will catalyze a new branch of the e-bike market. It will usher in a new wave of affordable electric bikes and will ensure that everyone has access to low-cost, eco-friendly transportation. Thank you for watching.